Hi, welcome again to another tutorial, and now we're going to talk about subnetting. Okay, so what is subnetting? Subnetting in its practical definition is actually you're trying to group computers that belong to the same network, and you try to group them so that you'd be able to take advantage and make more efficient performance when it comes to the network, okay, the performance of the network. So maybe subnetting or subnetwork or subnet, it still is the same thing. It is the practice of dividing a network into two or more networks. It is also a method of getting the most out of the limited 32-bit IP version 4 addressing space and reducing the size of the routing tables in a large inter-network. It also provides a means of allocating a part of the host address space to network addresses, which lets you have more than networks, which lets you have more networks rather. So this is an example of applying subnetwork. Now we have, in our previous activities, we have actually simplified this kind of problem by using switches, okay? But if you're talking about a larger network, it would actually be better to use routers, okay? So here we see that there are 3 floors and are divided by 3 networks. That's because one router is for one network, another router is for another network, and then the other is for the other network. As you can see also that the router has these addresses 192.168.89.1, and then the next is .33, the next is .65. Okay, so from the given range, that is 192.168.89.0/27, which means this is the subnet mask, okay, which determines which part is the network part, and then the host part. So basically the IP addresses that are in floor number 3 or subnet 3 actually are from 192.168.0 to 31, okay? So, and then next network which belongs to router B is 192.168.89.32 to 32 to 63. Okay, 63, and then next one is 192.168.89.64, which is for the router C, or the other layer is 64.64 to 96. Okay, it's actually divisible by I'm not really sure if I'm using the term right, but the intervals are actually 32. So 0, 32, 64, and 96. Okay, so this is an example of subnetting. We're going to do some computations later. Okay, so this is just showing you how subnet is done. Okay, as a review. Okay, and then computers that belong to a subnet are addressed with a common, identical, most significant bit group in their IP addresses, and this results in the logical division of an IP address into 2 fields: the network or routing prefix, and the rest is field or host identifier. Okay, as mentioned earlier, there's a part of the network and then the part of the host identifier. The hosts are the computers, the end devices. Okay, computers, laptops. Okay, these are host devices. The rest field is an identifier for specific host or network interface. Now, subnet mask, is the screen of numbers used for routing traffic within a subnet. Again, subnet mask determines which one belongs to the network and which one belongs to the host. Okay, let's say for example the 255.255.255. Okay, this part here, the 25 all the 255.255, this is the network part of the address, and then the 0 is the host part of the address. Okay, so subnet masks are also expressed in decimal notation like an address. Okay, mask for slash. Okay, so why is this? What about 24? Okay, what does slash 24 mean? The slash 24 means actually that it's 255.255.255.0. Why? Because if you convert this to binary, okay, so 255 is going to be a series of how many? 8 ones. 8 1 1 1 1 1 1 dot 1 1 1 1 1 1, 8 of that also, and then 1 1 1 1. So basically you have 255 is 8, another 255 is 8, that means 16, another 255 is 8, that means 24. Okay, so that's why it is slash 24. So this means that 192.168.1.0 is using the subnet mask slash 24, or in other words the 255.255.255.0. Okay, so CIDR, the routing prefix may be expressed in CIDR notation, written as the first address of the network, followed by a slash character and ending with the bit length of the prefix. For example, 192.168.1.0/24 is the prefix of the IP version 4 network, starting having 24 bits allocated for. Okay, I just explained it. Now, that's for the IPv4. Now, for the IPv6, which is the future of Internet Protocol addresses, okay, has more addresses that is reserved for public use. Okay, so version 4 is the old model, version 6 is the new model. But as of the moment, right now in our university, we're just using actually the version 4. But other companies, big companies, are actually using already the IPv6 or the IP version 6. So traffic is exchanged or routed between subnetworks with special gateways. Okay, when we talk about gateways, or think about routers. And the routing prefixes of the source addresses and the destination address differ. A router constitutes the logical or physical boundary between the subnets. Okay, the router also is able to identify what network does that particular IP belongs to because of the subnet mask. Okay, so benefits of subnetting on existing network vary with each deployment of scenario. So in the address allocation architecture of the internet, using the classless interdomain routing or CIDR in large organizations, it is necessary to allocate address space efficiently. It may also enhance routing efficiency or have advantages in network management. When subnetworks are administratively controlled by different entities in a larger organization, subnets may be arranged logically in hierarchical architecture, partitioning an organization's network address space into a tree-like routing structure. So this is CIDR. Okay, we have Class A, Class B, and Class C. As you all know, and as we all know, Class A is the biggest network. It has lesser number of network, but the biggest network is the Class A. Okay, big companies or big like Google, they're actually using this address. Okay, the Class A address 255 and then .000. Class B is, so that means the network part here is the first octet. Second, third, and fourth octet belongs to the host. for class B, you have half of the octets. Of the 4 octets belong to the network, and then half of it, 8 and 8, 16. So 16 is for the network, and another 16 is for the host. That's why when you denote it, let's say for example /16, so that means it's using the class B class. Okay, for /8 it's class A, and finally for class C is /24. So 255.255.255, that 0 is class C. Sorry, I moved forward too much. Let me just do this. Okay, here. So public address. So what is a public address? Public address, this is the internet, this is the IP, internet address, internet protocol address that is given to the public. Okay, so it is actually maintained by the IANA. Okay, where was it? Let me check on this one. Okay, Internet Assigned Numbers Authority, or IANA, okay, is the organization responsible for registering IP address ranges to the organization and internet service providers. Okay, so let's say for example the WIMSU IP address that the PLDT internet connection that was the internet address, IP address that was given by that was provided by PLDT to WIMSU is actually a public IP address. Okay, it's public. Now because it is regulated, or it is controlled, nobody can just use that IP address from other parts of the world. Okay, it is unique. Okay, because and it is actually being since it's a service, so WIMSU is paying for that service. Okay, now that is unique. Okay, and that IP address is not found in any other place. It's unique. Now the other type of address is private IP address. Okay, now when the IP address was given to WIMSU, now WIMSU is going to distribute now the internet connections to all the other offices, and that kind of IP address that is distributed to under the public IP address is what you call as the private IP address. Okay, now the administrator or the system administrator of WIMSU, which is who is I think it's Misto or si Sir Lay, no, is, or whoever the admin is, network administrator is going to devise a way on how to assign these IP addresses within the organization. So the public address will actually be split to private IP addresses to other branches of the university. Okay, now so this is an example. The following IP blocks are reserved for IP addresses. So the ones that you usually use or you see is the 192.168.something.something. Okay, so that is class C. Okay, and for as you can see, the starting IP is 00, and then ending IP addresses is 255.255. For number of hosts is 65,000. Prefix is 192.168/16. Wait lang. Okay, this is, I'm sorry, this is for IP addresses. Okay, so this is reserved for the system administrator to assign to the other hosts inside the network. Okay, so network address translation is responsible in converting the public IP address to private IP address. Okay, so it's the NAT, or network address translation. DHCP, and this is what we usually take advantage of, or if you're going to become in the future network administrator, this is the easiest way of assigning IP addresses to the other computers in the network, because you don't have to go to each computer and configure the IP address. Okay, all you have to do is just turn on the DHCP service of the server, so that all the other computers, when turned on, they will request for an IP address from the server, and then the server is going to assign an IP address to those computers. Okay, so that's dynamic host configuration protocol. So determining the network prefix. Okay, so network prefix is IPv4 network mask consists of 32 bits because there's 8888. Okay, that's why you have 4 octets. So let's say, for example, 192.168. 192 is one octet, another octet is 168, another octet is 5, another octet is 130. Okay, so and the following example shows the separation of network prefix and the host identifier from an address 192.168.5.130, and its associated /24 means actually that it is 255.255.255.0 net subnet mask. The operation is visualized on a table using binary address formats. Okay, so this is the binary address format. So this is the equivalent. This is the dotted decimal notation, and this is the binary form. Okay, and then so this is the network prefix 192.168, and then the host part. Okay, so how is the network prefix derived? Okay, so it was actually combination, or the proper term for that is the logical AND operation. Okay, for the IP address, the given, which was the IP address and the subnet mask, so you convert them into binary form, both the subnet mask and the IP address, and then you perform an AND operation, A and B. Okay, so 0 and 0 is 0, 1 and 0 is 0, so 0 0 0 0, and then you have here 1 and 0 is still 0. Okay, because in AND operation, if you have 0 and 0, it's 0. It's 0 and 1 is 0. It's 1 and 0 is still 0. And then if it's 1 1, that's the time it's going to be 1. So other than 1 1 combination, it's all going to be, the answer is going to be 0 for an AND logical operation. So this is 1 1, so that's why this is 1. 0 1, that's why you have arrived to this. You call this the ending of, if you AND IP address and the subnet mask, you will have the network address or network prefix, which is this one, this one below, this one. Okay, so if you convert that also to data decimal notation, so this is it, 92.168.5.0. So this is 192, this is 168, this is 5, and this is 0. Okay, so how do you get the host part? Okay, that is because you actually you just select the part of the host part of the subnet mask, which is this part. Okay, and that from there you will now bring down whatever the IP address is on the part where there is 0, this one here. Okay, so this is 1 and 1, or 1 0 0 0 1 0. That's why you have this 1 0 0 0 1 0. Okay, and then we're going to perform examples later, so that you better understand and be able to get the concept. Okay, so the result of the bitwise AND operation, as I mentioned it already earlier, you have to perform the AND logical AND operation. Okay, so this is an example. Another example is network prefix. Okay, so 130, 192. So this time, okay, for us, so this is actually what is given, and then you're asked to find the, oops, where's that? The network prefix and the host part. So how are you going to do that? Again, you convert this into this, and then you perform an AND operation. So after ANDing this, the result is this one. Okay, the result is this. So this is the network prefix. That's why you convert it to 168. Okay, and then for the host part, you get the this is the subnet mask. So that means this is, you just bring down whatever is 1 here on this side here on top, bring it down. That's why you have here 10, okay, for the host part, and it's actually equivalent to 2. Okay, so we'll have some more examples. So advantages of subnetting: it prevents unnecessary broadcasts because it minimizes sending of packets to all or to every hosts, no? Because it is now limited by the subnet, okay, or a limited broadcast domain. So broadcasts, however, are not forwarded beyond the user's subnet. By dividing a larger IP address space into smaller subnets, you can stop broadcasts from affecting the whole physical network. Okay, so another is increased security options. Of course, it is now separated, no, by group. So let's say, for example, one subnet belongs to one department and the other one belongs to another department. Now, with subnetting, the other department won't be able to access the other department's data. Okay, however, he may like to do it because it is now protected by subnet. Okay, it is now, you won't be able to access them that easy. Advantages, another one advantage is simplifies administration. So it's easier for the administrator now to do some troubleshooting because it's now isolated. Okay, controls growth, of course, because you can actually do some with the subnetting, with some computation. You can make the subnet hosts, okay, the hosts limited, or you can increase it anytime because you are in control of the number of hosts, okay, because of the subnetting. Okay, you will really feel, as an administrator, you will really feel a true administrator because you are in overall control of the numbers. Okay, so we'll try to answer those next. In decimal notation, subnet mask value is 12255. Okay. Okay, we're going to have later some examples so that you can really practice. First address of subnet is called network ID. This address is used to identify one segment or broadcast domain from all the other segments in the network. It is the size of subnet, including network address, host address, and broadcast address. It's like a set of address information. That's the whole block. There are two types of broadcast, okay, direct broadcast and full broadcast. So in the direct broadcast is the last address of subnet and can be heard by all hosts in the subnet itself. While in the full broadcast is the last address of the IP classes that can be heard by all IP hosts in the network. So let's say, for example, your network is divided into 3 subnets. So with the full broadcast, so that is everyone will be able to get the packet in the full broadcast in the network. But in the direct broadcast, it's only limited to that example, subnet 1. So, dun lang talaga yung broadcast sa subnet 1. Okay? Hindi siya makakapunta sa subnet 2 and subnet 3. So, if the case of everyone hears about the broadcast, so that is now what you call as full broadcast. The main difference between direct broadcast and full is that routers will not propagate local broadcasts between subnets, but they will propagate directed broadcasts. Okay? So, that will be all for this particular session. The next one is we'll be doing some computations on subnetting and some exercises for you to perform. Okay, thank you so much for listening, and bye-bye.